Hello, my name is Hugo Alejandro Arias Diaz. I'm an administrative chemical engineering student at Tecnológico de Monterrey Campus M. Today I will be explaining feed-forward control. This is for the automation process laboratory imparted by the Professor Jartan Halvorsen. To begin to explain the feed-forward control, let's look at this example that will give us a context of how the system works. It can be seen that Homer is driving in reverse on a road. When he does this, he has the rear view mirrors as reference angles to see where he should direct the car and not to crash. Although he ignores them, but well. That is the only way in which he can see the road in the direction he's heading. A driver who drives in reverse will see the road through the mirrors and will adjust the position of his vehicle using the steering wheel so as not to leave the road. This will be more difficult, for example, if the car is going very fast backwards or if there are several cars on the way. In an analogous way, here you can see Toretto driving his car forward. By doing this, he is able to see the front path of the direction in which he is going, having a wide range of viewing angle. This will allow him to adjust the direction of his vehicle more easily, as well as having a better control of it. When Toretto drives forward and has his eyes on the road, he is also capable of evaluating the obstacles that arise and taking action as a correction or prevention, in such a way that these obstacles affect the performance of his race as little as possible. Toretto can also know the best time to turn more easily when driving forward than when driving backwards. Similar to Homer Simpson driving backwards, the typical controller works by making adjustments to a process variable, PV, that is measured through a sensor and then generates an error when comparing it with a set point, SP. Then, the error will be the difference between the measured process variable and the set point. So, this is the moment when the controller makes the adjustment to keep the process variable in check. A simple feedback controller, like the one shown in the figure, must wait for the measurement of the variable to correct and adjust, and then measure again, and send the signal backward. It can be said that this type of system works to progressively minimize the imbalance, but it cannot anticipate what will happen when the disturbance, B of t, is entering the system.
On the contrary, as it can be seen in the figure shown, in a feed-forward controller, the disturbance measurement is performed before it influences the process. This value is received by a feed-forward control element, Fp of S, which uses the disturbance measurement to predict the impact it will have on the system and then determine the preventive actions to keep the system under control. As in the example of Toretto driving forward, this feed-forward controller allows the effect that the disturbance will have when it enters the system to be predicted, and it can make an adjustment without the need to wait for the evaluation of the process variable. This feed-forward control anticipates the impact that the disturbance will have on the process variable and takes actions that allow the system to be controlled and to avoid system interruption. The feed-forward controller is appropriate for those cases in which it is desired to have better rejection of the disturbance and that we do not have a secondary variable of the process that is measurable, which responds earlier to the manipulations in the final control element and provides information about the interruption that the system will have. It also applies to those cases in which there are interruptions in the system that cause increased costs, and that this interruption is due to a specific disturbance. Another application for the feed-forward controller is for those cases in which the disturbance are of great magnitude or very frequent. One of the most specific applications starts from a mechanical analysis. Since the feed-forward control will eliminate the oscillatory behavior that simple feedback controllers present, this will cause less mechanical movement and therefore energy consumption is reduced.
Thank you for watching. I hope this is useful for you. Goodbye.